stands for metal oxide, semiconductor, field effect, transistor. Earlier we are discussing about FET. In FET we have seen the JFET, that is your junction field effect transistor. This is your metal oxide semiconductor field effect transistor. Your Mosfet, it is also known as insulated gate. Insulated gate field effect transistor. Insulated gate field effect transistor. The name itself is telling that here the gate is insulated. Now, if you are going for your FET, you are knowing that whether it is your JFET, there you are having three terminals, you are having source, you are having gate, you are having drain. Here, in case of your Mosfet, here also you are having source, you are having gate, you are having drain. Here, as it is telling that insulated gate, the gate is insulated. Here, we have insulated the gate. How we have insulated the gate? We have insulated the gate by using your silicon dioxide, SiO2. Okay, SiO2 is your just sand. Okay, so we are insulating your gate from your source and drain. If you are seeing the structure of your Mosfet, the Mosfet from the structure point of view, we are having P-type material. In that P-type material, we are having N positive, and this is your N channel. This is your N channel. So this structure is for N channel Mosfet. This structure is for N channel Mosfet. Here the gate is insulated. As gate is insulated, gate does not have the control over the flow of electron from your source to drain. Here it is not interfering. The gate is not interfering here. So we can say that from source to drain, it is like your low resistance. It is just like low resistance. So from source to drain, the flow of electron will be there, and it is like it has to overcome some resistance, then the conduction will be there. Now if you are going for the types, the different types of Mosfet. So like your JFET, your Mosfet are also of two types, that is your N channel Mosfet and your P channel Mosfet. This N channel and P channel, it depends upon that which channel we are using. As you are knowing, FET is your unipolar device. So unipolar means either the flow will be from your free electrons or it will be from holes. Okay. So as this structure is for N channel, if you are going in for P channel, it will just be reverse. We are taking the base, the substrate will be of your N type, and this channel, this will be of P type. And here for your source and drain, there will have the P possibility there. Okay. So just it will be the corollary of your N channel, just reverse of it. The next thing related to this is the mode of the operation. What are the different modes by which we can operate your Mosfet? So suppose if you are going for the modes, we are having two different modes. We are having the diffusion mode, we are having the enhancement mode. Okay, so these two modes we are having for the operation in case of your Mosfet. For the modes, we can go for your diffusion mode. In case of your Mosfet, when we are talking about the diffusion mode means your Mosfet, it will act as a closed switch. It will act as a closed switch. So, as it is acting as a closed switch, there is a need that we should have the voltage. The voltage between your this source and gate. There is a need that the voltage between your source and gate should be such that we can use it as off state. Okay, so what it is, when we are going for the diffusion mode means it is like closed switch. It is like closed switch. So we need some external voltage. That external voltage means the voltage across your gate and source, so that we can make it in off state. Okay, already closed means it is on state only. Okay. This is one mode of operation. Another mode of operation is that we can use your MOSFET in enhancement mode. When we are going for enhancement mode, here it is like open switch. Here it is like open switch. So as it is like open switch, we need the external voltage. When we need the external voltage will be across your gate and source. And what this external voltage will do? This external voltage will make your MOSFET to in on state. Okay. Earlier it is open means it is off. We are using the external voltage so that it can be in on state. Okay. So one of the application of your MOSFET will be that we can use it as a switch. Okay. So earlier we have seen that like your JFET, we can use it as an amplifier, we can use it as a switch. Okay, and these two are your modes. These two are modes of the operation in case of your MOSFET. If we are going for the application part, where we are using it, say suppose if we are going for the application, we are using your MOSFET. Say nowadays, whatever the circuit you are having, all the circuit will be based on your FET technology only. So we are using the MOSFET in your microprocessor. We are using your MOSFET in memories. Suppose if you are going for the applications means we can use it as microprocessor. You are knowing that microprocessor is the heart of your computer. Okay, so those microprocessors they are made up of your MOSFET only. The memory element. So memory means you can go for your RAM, you can go for a ROM, whatever all these memory elements that are there, that are also used. They are also made up of your MOSFET only. Your calculators, your digital logic gates. You are having the logic gates. Different types of logic gates are there. So those gates are also made up of your MOSFET only. Okay. So now what is, as we are switching to your digital electronics. In the digital electronics, whatever all these things are there, those are made up of your MOSFET technology only. They all follow your MOSFET technology only. The reason behind this is that it consumes very less power. So here the requirement is low power requirement. This is the main reason for going for your MOSFET. Okay, as here you are having the insulated gate. As you are having the insulated gate, here the power requirement will be less. Okay, so you will have much more low power requirement. Okay, and you are knowing that even today also, if you are going for the digital electronics, maximum requirement is 5 volts. 5 volts is maximum requirement. Okay, if you are going for your analog, in analog we are going for your 15 volts. So you just see that how much reduction is there. Okay, so if you are going for any analog circuit, 15 volts is required. And if you are going for digital this is 5 volts. 5 volts is maximum. Okay, so as we are switching from high voltage to low voltage, we are going for a MOSFET technology. Okay.